Hello and welcome to this video. I'm Francis Jane from Makula and I'm here to discuss about Huntington-hill method. First, what is apportionment? Apportionment, for example, the distribution of aid to various barangays and the calculation of how many aid items should be distributed to each barangay, are example of apportionment. However, we commonly use this technique without realizing it. In 1920, no new apportionment was done because Congress couldn't agree on the method to be used. They appointed a committee of mathematics to investigate an apportionment method. They recommended the Huntington-hill method. However, they continued to use Webster's method in 1931. After second report recommending Huntington-hill, it was adopted in 1941 and is the current method of apportionment used in Congress. The Huntington-hill method is similar to Webster's method, but attempts to minimize the percent differences of how many people each representative will represent. These are the ways in which the Huntington method can be used. First, determine how many people each representative should represent. Do this by dividing the total population of all states by the total number of representatives. This answer is called the standard divisor. Second is divide each state's population by divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called the quota. Third, cut off the decimal part of quota to obtain the lower quota, which will called n. Complete the square root of n, sum of 1, which is the geometric means of lower quota of one value higher. And for the fifth step, if the total from step 4 is less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. And for the fifth step, if the total from step 4 is less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. If the total from step 4 is larger than the total number of representatives, increase the divisor and recalculate the quota and allocation. Continue doing this until the total in step 4 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjust divisor. For example, Purok 1 Elementary School plans to assign 40 teachers to teach each of grade 1 to 6. The number of students in each grade is given in the table below. First, we're going to take standard divisor where P, total population, A, the required allocation or the number of items to be distributed among the groups. For example, standard divisor equal the total of number of students over required allocation, or P is over A is the 40 teacher to assign, so we have 17.5 SD or standard divisor. And for the standard quota, all we have to do is divide the standard divisor we got to the number of students by each grade. For example, 120 of grade 1 student over the standard divisor of 17.5, so we have 6.86, and do this to each grade. And this all we got. Next, for a lower quota is the standard quota rounded down to a whole number. So we got 6, 5, 7, 4, 11, and 4. Next, for upper quota is the standard quota rounded up to the next whole number. So we round up the 6, so we got 7. We round out the 5, so we got 6. We round out the 7, so we got 8, and so on. Main, the geometric means rounded to 2 decimal places of each of subgroups, lower quota and upper quota. You can get it by getting square root of 6 times 7, which is equal to 6.48. These are the results we got after we finished by getting the square root of upper quota times the lower quota. To determine the rounded value, if the standard quota is less than the geometric mean, round the quota down. If the standard quota is greater than or equal to the geometric mean, round the quota up. As you can see, in grade 1, our standard quota is 6.86 and our geometric mean is 6.48. We'll round up because our standard quota is greater than the geometric mean. Use this technique to other grades as well. And then this is what we get. And when we add all the rounded value, we get 39. In this issue, if the sum of the rounded standard quotas equal the required allocation, we are done. Otherwise, choose the modified standard divisor and repeat the process until the required number is achieved. The possible MSD or modified standard divisor is 17.45. Repeat the process from getting standard quota to rounded value until the required number is achieved. So now we get the same allocation. We have another example here, and it starts out the same way as our previous methods. We're going to find out our divisor and divide by total population by the number of seats to come up with our divisor of 20,900.83. And we're gonna go ahead and find our standard quota by dividing each population by the divisor. And now this is where things. So the first thing we're gonna do is find what's called the lower quota and upper quota. That's really easy, so we're just rounding down or chopping off the decimal. And for the upper quota, kinda like how we started by rounding up the decimal. Now we're gonna find something called the geometric mean. Now the geometric mean work like this. So for Kyapo here, the square root of 7 times 8 or the square root of 56 is 7.48. So we're using the lower quota and upper quota to calculate the geometric mean. Our initial allocation comes from comparing the quota to the geometric mean. Again, if the quota is bigger than the geometric mean, then we round up. If the quota is less than the geometric mean, then we round down. So in this case, in Quiapo, the quota is smaller than the geometric mean, so we round down. Here in Tondo, the quota is larger than the geometric mean, so we're gonna round up. Here in Pasay, my quota is less than the geometric mean, so we're gonna round down. Now we total those up, 41 seats. Now it comes out the correct number here, so we are done. Again, for our previous discussion for modified standard divisor method, so if it did not come out correctly, we would adjust our divisor and do the whole process again, but in this case, we are done. Another example, and we have 20 required allocations and 4,800 total population. Just like we did earlier, the first thing we will take is the standard divisor. By dividing 4,800, the total population, and 20, the required allocation, we get standard deviation 240. And divide 1,500 to standard divisor 240 to get standard quota 6.25 and so on. After we get the upper quota and lower quota, let's go to the geometric mean, taking the square root of 6 times 7 or a square root of 42 is 6.481, and do the same in another region. Next, if the quota or the standard quota is greater than the geometric mean, then we round up. If the standard quota is less than the geometric mean, we round down. So this is what we get. The total of rounded value is 20. In this case, we are done because we get the same value of required allocation. It ends there. I hope you gain some knowledge. Thanks for watching.